This is Widu Ambrose. So I'm presenting my work that I've done. The work was like the question one was saying. You should do. It was under the projectile motion simulation. The requirement was like to write a JavaScript that take the initial velocity from the user and the angle. Then it calculate the time of flight, the maximum height, and horizontal range. So in my folder here, I've created one folder for all my work, as you can see here. So the first thing I managed to set up here was to create up the file for the JavaScript, which I name it as projectile simulator. If I open this file, in the notepad, so this was my code I managed to work upon. As you can see, the first one was the import statement. The first one is used for importing the scanner class, this first one, and then the second one is for the mass function. This one is just for the comment, the multi-line comment. Then I have the class, my class called the projectile simulator. So under my class, I have the static. I have the private static function. That this one was the gravity, acceleration due to gravity. I made it to be constant because I'm not going to change it. And then here I was creating my scanner to accept the input from the user, to take the user input. From here, as you can see, this one was the printout statement, this line of code. As you can see, system.out.print. So this one here, it print out this word here, a projectile motion simulation tool. And then the second one, it enables the user to enter the initial velocity. It reads the velocity from the user. And then this one here, I give it the initial velocity be 0 because as you know, the velocity always is positive. So I want it to start from 0 onwards. And then I create the validation rule here. In case this Samsung first come and check the input value that is entered. If it's less than 0, it should print an error. Then if it's greater than 0, it should continue and print for me that velocity. And then for this one here, it allows users to enter the angle. And the angle, according to the question that have been set, the question was saying it should be between 0 to 90 degrees. So this is the line of code that is allowing user to enter that code. And then for this one here, I set my degree to be 0 because my angle was starting from 0 going onward, 0 up to 90. So any angle that is below 0, like let me give an example like -1, the system have to print out an error. And then I put the validation rule to cater for that one there, those errors. And then I close my scanner in this line of code, as you can see. Then this one was to check in case the velocity, comparing the velocity, checking the velocity and the angle. If the velocity is less than 0 and the angle is also less than 0, so the system should print for me that both the velocity and the velocity have to be positive and the angle must be between 0 and 90. And then for this line of code, in the third one, that one for converting from degree to radian. Remember, in my angle that I was entering up here, I was entering it in degree, but I have to convert it to radian so that it fits the JavaScript trigonometric functions. So that's why I'm using this line of code. Is the one that is converting it from degree to radians. That's why I was calling the other math function up there. I was importing it under my import function. And then this line of code, it's the one performing calculation, and there I was using the physics mass formula since the question instructed me to use it. So this one here I was using the formula for time of flight. As you can see, the capital T is equal to G 2U sine theta. So the U is the initial velocity that I'm going to enter from up there, and then this angle theta is the angle that I will be entering from there. And then this one, it calculates, this line of code, it calculates the sine and the cosine of the angle. It uses the other mass function I've imported. And then as we continue going down, this one here is for the horizontal axis, using that formula for the horizontal axis, which is capital H is equal to 2G U sine theta, sine 2 theta. So then that's the formula used for calculating it. And then I have the one for range, the same formula. I was using the one for that very formula for range for the one for physics. I break it down here for my system to understand it very well. And then the last one was just for displaying the results, the calculated results, as you can see from there. The first one, it has to first bring for me the characteristic or the results. So this is stroke slash n, the one that can make my things not to be printed in only one line, but make it to be in other paragraphs. And then the first give for me the initial velocity that I've entered up there in 2dp. As you can see, percentage dot 2f, that one is 2dp. And then the one for the angle I've entered, it also print it out, then it gives some space. Then after the first one, it calculates for me the time of flight using this formula I was using up here. And then the second one, the maximum height, using this very formula here. And then the third one, the horizontal range, using that very formula that time. So if I come back to my code here, then I try to run this code, I should be in position to, if I come back up here, then I go and run the code. If I come up here, then I run my code. So I first start by compiling it, Java C. So if you're compiling, you have to type Java C. Then after Java C, you put the file name. So my file name is projectile simulation. Projectile simulation. Then I put it there. Then I had the extension, which is .java. Then I click my enter. So the system is here compiling me my things. Then after the compilation, I have now to print it on the screen. So for printing, just put on a Java, then the folder name, the file name. So this was what I was explaining. The first one, it has print for me the projectile motion simulator tools. Then it allows me to capture the input from the user. Let's give an example. I enter 30 microsecond. Then I press enter. So here I have to enter now the angle from 0 to 90. Let's give an example, like I enter 20. Then I press enter. So the system here calculate for me the time of flight using my formula, and then the maximum height, the horizontal range. Yeah, so that was question 1 that was assigned to us to do them.